Yeah, hi everyone. I'm Matt Lee. I'm in the Building Energy Research Group at Loughborough University, and the paper I'm presenting today, it's a paper called Measuring the In-Use Thermal Performance of Dwellings, Improving the Precision by Accounting for Variability, which is a nice, snappy title. And this is a paper that was produced by one of our PhD students, Max Eastwood, during his PhD at Loughborough. So there's Max. So yeah, it was during his PhD, it was supervised by David, Dr. Ben Roberts and myself, and it used data from the Technical Evaluation of SMETA Technologies, or TEST project. Paper's currently undergoing peer review, but there is a preprint available, and I'll put a link up for that later. So in terms of methods, so what we did, or what Max did really, was to calculate the in-use HTC from monitored data from 19 occupied UK dwellings. So this was just using a fairly basic multiple linear regression method applied to rolling 20-day windows, and that was regressing daily mean heating power against solar irradiance and indoor-outdoor air temperature difference. And the data that were analysed were gathered between October 2019 and March 2020, so one winter, one heating season. And in these dwellings, the HTC was previously measured by the aggregate heat loss test, the test formerly known as coheating. Okay, so for each dwelling, what we ended up with was you get this trace of rolling in-use HTC estimates going through time, and so they would vary up and down going forwards in time, and at the same time the boundary conditions are varying, the outdoor, the weather, the indoor temperature, things like that. And so the question that we asked was, well, is the variation that you see in the in-use HTC, is that related to the variability that you see in those boundary conditions? And so what we did was to fit linear models of the in-use HTC for each dwelling to as a function of the changing boundary conditions for that dwelling using stepwise linear regression. And the boundary conditions considered were indoor temperature, indoor-outdoor temperature difference, and wind speed and wind direction. Not every boundary condition was included in every model. What was included depended on what was identified as significant in the stepwise linear regression. And then after generating those linear models, we use them to try to predict for each dwelling what the HTC would be under the aggregate heat loss test conditions. And then we were able to compare that prediction from those linear models with what was actually measured by the test. So the key findings were that for every dwelling, there was temporal variability in the in-use HTCs. It wasn't a constant thing. It went up and down, which is kind of what we expect. The average coefficient of variability, so that's the standard deviation divided by the mean, was 7%, and it ranged between 1 to 12%. And this was greater than what's predicted by the UK National Calculation Methodology for Energy Performance Certificates, for which there's an average coefficient of variability of about 0.3% for October to March for these particular dwellings. And that's because the only variability in that calculation method is due to changes in wind speed that therefore influences changes in infiltrative and ventilative losses. Quite interesting thing that we found was that the linear models, there were 19 dwellings analysed, and we successfully fitted models for 17 of those dwellings. And the interesting thing was that a unique model was required for each dwelling, so depending on which boundary conditions were determined to be most influential. So it wasn't a case that wind speed was always influential, or that outdoor temperature was always influential. But for 13 of the dwellings, at least 80% of the in-use HTC variability was explained by the variability in the boundary conditions, as indicated by R-squared values for the linear models. When we tried to use those models to predict what the HTC should be under the aggregate heat loss test conditions, the results, the comparison was often quite poor. And we sort of hypothesized that this was largely due to the fact that we were using those methods, so those models, and extrapolating to conditions that weren't captured during the in-use monitoring, because obviously the co-heating test conditions are quite detached from what you actually see in in-use homes. So in particular, the indoor air temperature doesn't get up to that level. So in conclusion, the variability of in-use, this work quantifies the variability of in-use HTCs in in-use dwellings in the UK for the first time. We discovered that linear models can explain upwards of 80% of in-use HTC variability in terms of the boundary conditions during the measurement period, and that the relationship between the in-use HTC and boundary conditions varies between dwellings, crucially including which boundary conditions are significantly correlated with the HTC. And then that final point, extrapolation to conditions beyond those observed is not advised because we saw those poor results. But there is therefore we think possible potential value in perhaps incentivizing householders to temporarily vary their heating practices to generate a wider variety of conditions, enabling fitting of improved models and meaning that we're hopefully interpolating rather than extrapolating with those models. Just going to finish up with some of the implications for the work that we're hoping to do in this annex. So objective 1 was applications and the requirements. And so hoping that the kind of methods that Max developed in this work might facilitate prediction of the HTC under specific conditions. For objective 2, for extending HTC estimation methods, it's more that there are questions raised by the work that, to what extent do the relationships between an in-use HTC and the boundary conditions depend on the building typology, seasonality, and climate? These were just a small sample of 19 homes in the UK, all kind of quite what we might call typical UK dwellings, nothing high performance, and all in the UK climate during one specific heating season. For validation and verification, there's a question of, well, will other methods exhibit the same variability as we saw using the multiple linear regression method? And if so, can that variability be reliably characterized to help improve the accuracy of our methods? And there's this question of, well, is the variability actually due to genuine variation in the heat transfer coefficient of the dwelling, or is it an artifact of the data analysis method? Maybe there are questions of, we've made assumptions about what the boiler efficiency was, but does the boiler efficiency vary depending on outdoor temperature perhaps, which might lead to some of this variability that we've seen. And then there's a question of, well, what's a suitable baseline HTC against which to assess accuracy? If we acknowledge that the HTC should vary depending on the boundary conditions, is an aggregate heat loss test the correct thing to compare against? And if we are going to make that comparison, how do we make sure that it's a valid comparison? In terms of building performance diagnostics, we might ask how much of the performance gap can actually be accounted for by differences in the boundary conditions. So if we've got a predicted HTC from a calculation method versus an in-use or in-situ HTC, well, what's the difference in the boundary conditions that are assumed in the model prediction and the boundary conditions during the measurements? And to what extent does that influence the performance gap? And in any given dwelling, how sensitive is the HTC to individual factors? For example, ventilation and glazing. Which factors are actually most strongly associated with HTC variability in any given dwelling? And that might tell us what we might target for improving the performance of a dwelling. And then finally, for Objective 5, the work demonstrates the value of the test data set, which I'll also put a link up for, and it illustrates the value of gathering longitudinal building monitoring data sets to capture variety in the boundary conditions. So that's my time. I'll just quickly put up, there's a QR code that you can scan for the link to the paper there, and these slides will be distributed afterwards. Am I right in thinking that? And there's also a couple of links to the data set that was used and the report for the test project. Thanks.